This is my third attempt at making this video. I'm having trouble with my stylus, so hopefully it'll hold in there. We're wrapping up the discussion on partial fraction decompositions with improper rational functions. And recall what an improper rational function looks like. It's when the power of the numerator is greater than or equal to the power of the denominator. So an example of that would be x cubed over x squared. This is improper because the power of 3 is greater than the power of 2. Just like a number, right? That's an improper fraction. So we're going to use long division. In this case, we're going to use long division, and long division is going to yield two parts. You're going to get an easy to integrate polynomial. So after the long division, it's going to yield two parts. The first part is an easy to integrate polynomial. And the second part is going to be, if it exists, a remainder, and it's going to be a proper rational function, in which you're going to use the partial fractions technique to decompose. So you're going to end up with a proper rational function that will require decomposition. Okay, so let's look at an example. I'm going to go to the next page. I think that might be the best thing to do. And I'm going to pause here to write the example down. I'm resorting to using my finger. Let's see how things go. So x squared goes into 3x squared 3 times. And I'm going to multiply that by the divisor and then subtract it. And I get 3x squared minus 9x plus 6. When I subtract that, I get 13x minus 12. That's my remainder. So here's my easy to integrate polynomials, just simply 3, and the rational function is 13x minus 12 over the divisor of x squared minus 3x plus 2. So the partial fraction decomposition becomes 13x minus 12 all over x squared minus 3x. Actually, I'm going to go ahead and factor that right in line. Right? This factors into x minus 1 and x minus 2. The decomposition is a over x minus 2 plus b over x minus 1. And multiplying out by the denominator to both sides and reducing, it's going to yield an equation, 13x minus 12 is equal to x minus 1 times a plus x minus 2 b. I'm going to use collecting terms for this one. And again, it doesn't matter. You can choose whichever one you would like. And you'll use combination sometimes. Whatever's easiest for you. Collecting the term, we have a plus b, x minus a minus 2b. That's going to yield two equations. It's going to yield a plus b is equal to 13, and it's going to yield minus a minus 2b equals minus 12. Okay, So I'm going to multiply this whole thing through by 1, negative 1. And you're left with a plus 2b equals 12. Okay, so solving for a is b, 13 minus b. And substituting that into the equation, over here I get 13 minus b plus 2b equals 12. Solving that, you get that b is equal to minus 1. Therefore, a is equal to 14. So let's put that all together in an integral now. Here's this simple polynomial piece, and the partial fractions is 14 over x minus 2 minus 1 over x minus 1 dx. And take the integral of that, I get 3x plus 14 ln of x minus 2, the absolute value, and then minus ln of x minus 1 plus a constant. And that's your answer. So that's the technique. Basically, for improper rational functions, you have to use long division. Get it in, it's going to yield 2 parts, a simple polynomial that we'll be able to integrate, and then a proper rational function that we'll use partial fractions on.